Hi, this is Aditi, and here's my presentation about the use of concrete in a structure. So first of all, how concrete is made. It's made by mixing Portland cement, coarse and fine aggregates of sands and stones, and water in proper proportions. When this is mixed, a chemical reaction called hydration occurs, and the cement bonds the aggregates and hardens the mass, and then the concrete is made in by two methods: cast in place and precast methods. Cast in place means the concrete is mixed on the site where the construction is going on, and precast is um, the concrete, it's like the components are made in the factory and then transported to the site. So cast in place method is very economical, and it's used when really heavy structures are made, and whereas precast methods are used when for light structures like beams or light structures are supposed to be made by concrete. So where concrete is used is in a building structure is like in foundations, slabs, columns, beams, elevator shafts, and it's also used for aesthetics like decorative tiles, because the reason is concrete can be molded. It doesn't have any form and can be molded according to the molds used. Um, the process of making concrete. Um, the process of using concrete in construction. Um, RCC, which is very popular and which is called the reinforced cement concrete, is widely used in construction across the world, and it is a combination of steel and concrete. The reason is concrete has a very high compression strength, but it does not have any tensile strength, and steel has really high tensile strength. So together they are very strong. And the process goes like first a steel framework is laid, then the concrete is poured, um, and it is cured properly for the chemical reaction. Like within the first 7 days, like proper curing is done regularly, and sometimes if the place, if the building is in a hot weather where evaporation occurs, the it is covered the concrete structure is covered by burlap cloths to prevent the evaporation of the moisture and the wetness. It takes about 28 days to achieve the hardness and the strength that it needs to. Um, the properties of concrete are it has a really high compression strength, meaning, example, like if there is a concrete a sidewalk made of concrete, and if you jump on it, it will not break. That is a compression strength. Durability, it lasts like for a long period of time. So it is um, that's why it's very economical, and it's it is resistant to fire and insect damage, and it does not have any form, so you can give any shape you want. It does not have tensile strength, but together with steel rebars, it gains the tensile strength required. And it is economical as it is made from all the natural materials like stone, sand, the cement, which is also made of natural materials, and water. The concrete mix. The recipe of concrete is very important, um, and it is properly designed by engineers. Like the water is supposed to be 7 to 15%, cement is 14 to 21% in a concrete mix, and lower the water cement ratio, higher is the strength. Um, Air is very important. More the air, higher the um, durability and strength of the concrete. And fine and coarse aggregates are 24 to 30% and 31 to 51% respectively. And according to this mix, there are two types. It's classified in two types: the rich and the lean mixes. Rich is the mix where there is um, where cement and water ratio are equal, almost equal, and lean mixes where the cement is less and the water is more. And again, they are again classified in air entrained mixes and non-air entrained mixes. As I said, the air trained mixes are very strong, has high strength and durability. Um, then there are admixtures, which maintain the property of the concrete, because sometimes the concrete, when after mixed, is different because of the weather conditions or other factors. So these admixtures are added to improve the quality of the concrete. The most important is the air entraining agents. Like as I said, the air entraining agents, they improve the durability, reduce the damage due to freeze and thaw, improve the workability and the water tightness. So they're very important. The retarders, they slow the setting time. If in a very hot weather, this would be very important. This might be needed. Accelerators, they help in speeding up the strength development process. This would be important in a cold weather where the temperature is really low and the mix requires the heat to have the chemical reaction and develop the strength and hardness. Pozzolans, they reduce the internal temperature. Um, Workability agents, they help with the pouring of the concrete, with the ease that the concrete is poured. The superplasticizers, they help to break the lumps. Um, when water and cement are mixed, they form clumps, and so superplasticizers are added to break those clumps. Permeability agents, reducing agents, they help to reduce the water flow, and bonding agents, they help to increase the bonding strength with the previously laid layer of concrete. The coloring agents, they are for aesthetic purposes, and they also help in maintaining a uniform color of the concrete throughout the structure. And hardeners are used where there is very heavy wear and tear, and like they help reduce the wear and tear, and they also help to and they make the surface impenetrable for the liquids and chemicals. And this is the best example is when concrete is used in factory floors, hardeners would be used. That's all. Thank you.